Now we'll study free fall motion. We can simply state that the motion of a body moving freely under Earth's gravity is called free fall motion. When we talk about free fall motion, we can simply state under free fall, acceleration is always taken as g in downward direction. Because we know very well that if there is a ground and a body is released above the ground, it will experience a downward force which is equal to the weight of body. And due to the weight, it will fall with an acceleration g. So acceleration of freely falling bodies near the Earth's surface are always considered as freely falling bodies having constant acceleration g in downward direction. In all the speed equations, we can replace the acceleration by g. Like if we take downward direction positive, if we take downward direction positive, then what we'll do, we can always use g in downward direction, so it will remain positive. So speed equations can be written as v is equals to u plus gt, s is equals to ut plus half gt square, v square is u square plus 2gh, or delta h, distance travelled or height covered in another second, can be written as u plus g by 2 into 2n minus 1. Now if we take upward direction positive, if we are taking upward direction as positive, in that case acceleration we consider as minus g. In this situation, acceleration is positive g because downward direction we are taking positive. When a body is moving down, it will be accelerating. Similarly, if we take upward direction positive, when a body goes up, the acceleration will take as minus g, or we consider it the body to be retarding. So in this situation, we write the equation as v equals to u minus gt, s is equals to ut minus half gt square, v square can be written as u square minus 2gh, and height traversed in another second can be written as u minus g by 2 into 2n minus 1. These are the speed equations we can use for free fall motion depending on in which direction we take positive direction of our reference frame. So the use of these speed equations depend on the choice of reference frame as well as the direction where we are taking it positive. In this example, we are given that a boy throws a ball up at a speed u, and we are required to find the time to reach its maximum height and the maximum height attained. So if we draw the physical situation in the question, we can state on ground there is a boy who throws a ball in upward direction at a speed u. We know well that when the ball goes up, it will be retarded in downward direction with acceleration g. So after some time its final velocity is going to be 0. And certainly it will reach a maximum height h before its velocity becomes 0. So in this situation, if we find out the time to reach maximum height, say if it was thrown at t equal to 0 and say at time tf, it reaches the maximum height. So we can use, here we use v is equals to u plus at. Here final velocity we can take as 0, initial velocity we take as u. As acceleration is opposite to velocity, we can write acceleration as minus g, and the total time to reach maximum height is tf. So here this tf can be written as u by g. This is the answer to the first part of this question A. If we wish to find out the maximum height attained, now we can use directly v square is u square plus 2as. In this situation, again the final velocity will be 0, the initial velocity is u, plus we take again acceleration as minus g into the maximum height we can take as h. On solving this, you can see the maximum height can be written as u square by 2g. This is the answer to the second part of the question. So always you should keep these two results on your tips, because in several cases these are going to be used directly. When a particle is thrown up, it will take a time u by g to reach the maximum height where final velocity becomes 0. And the maximum height it will reach will be u square by 2g. And obviously it will not remain at rest over there, again it will fall. So it will take same time in coming back down. So if we find out the total time of flight in going up and then coming down, this total time of flight can be written as 2tf, or it is 2u by g. This itself is a very important result you should keep in mind. In several questions these results are going to be used directly.